Hello and welcome to the second lecture on Karl Popper. This is the Introduction to Philosophy of Science, lecture number 7. So, in this lecture, we will discuss another very important theory of Karl Popper that can be loosely understood as the theory of conjecture and refutation. Now, this is another trademark theory of Popper, and what he says is that. How sciences work or how you come to the understanding of science. Now, for the understanding of science, what you do is, like, suppose if you have a problem, okay? Now, you are working on a problem and you need to come out with a theory. So, suppose you suggest an hypothesis, say an hypothesis 1. Okay, this hypothesis can be understood as a conjecture. Now, I do not know how many of you understand this term, conjecture. So, you can find the definition of conjecture, right? You can find the definition of theorem, axioms, conjecture, lemmas, mm, and so many things more like these. Uh, let me give you an example of a conjecture. Like there is something called Goldbach conjecture. Now, what is Goldbach conjecture? Goldbach conjecture says that every even number is a sum of two prime numbers, right? Like we know that every even number is a sum of two odd numbers. Every even number is a sum of two even numbers as well, right? So all these things are true, and you can prove that every even number is a sum of two even numbers, excluding two, right? Similarly, you can also prove every even number to be the sum of two odd numbers. So that also you can prove, because it is easier to prove it in terms of even or odd, because you know an expression for even number will be 2n and an expression for odd number will be 2n plus minus 1, right? So those things we understand, we know. But it is very difficult to prove. In fact, when Goldbach conjecture came, it was not having a proof, because there was no expression for, or you do not have a very clear-cut expression for a prime number. You know how prime numbers behave and how haphazard they are on the number line, and it is not having a very clear-cut understanding that okay, after this many numbers you will find an say prime number, or even if it has during Goldbach's time, maybe it was not found or something like that, and it remained as a conjecture. So conjecture precisely means that something which is true, which you can understand, but which you do not have a proof for. So a scientist, what a scientist does, the scientist actually comes out with an hypothesis, and he propounds this to solve this problem. That okay, this is my hypothesis and this is how something is going to be proved. Now, what are the properties of a good hypothesis? A good hypothesis is a bold hypothesis. Bold hypothesis, and it is having a lot of risk. These are two properties which Popper said, that if a theory is, or if an hypothesis is a good hypothesis, it must be having it must be having a boldness. Boldness means that something which may not be available at that point of time, or something which is not understood very clearly at that point of time, or something which people are restricting themselves because it is very radical by nature. It is not something which is just certain kind of changes which you are making to an existing theory. It should be a bold one, it should be a novel one, it should be a new one. It's a very strong theory, first thing. Then it is having high risk that it can fail at any point of time. Does not matter, because look, whether it is science or whether it is warfare, you need to have preparations of the highest level, and you should be also ready for failure, because by that only you make something a good theory. By doing that, you make something a better theory. And it's not only about sciences, it's also about life, that the more bold you take decisions and it is having more risk, the Means I'm not saying that you should leap in faith or you should not calculate the risk factor and you just go on, but there has to be some amount of risk which you should take so that you can come out with the best results, right? Because being safe, you will not reach anywhere. And at least for Popper, this was true, that he said that a good theory is something which is bold and which is very risky, because then you can come out with a better theory and then you can actually go on to think something like out of box or so on. Suppose if after doing this it works and it solves the problem, it's fine, right? It becomes a scientific theory and you are able to explain and this and that. Suppose it fails, you come back to the level of hypothesis again. You have to come out with another conjecture. You may then propound another hypothesis. So this was the understanding of Popper, that this stage is the conjecture stage where you develop an hypothesis, and when it has been refuted, so you come back to the conjecture theory, or you come back to the conjecture level and come out with a new theory. Now, this is a very interesting thing, and this is a very important thing also for any one of us, because if we need to develop a theory, we need to take some amount of risk, and the theory has to be a bold one so that it can go on to, say, address the problem. But suppose at some point of the time, because of some observation, it has been refuted. So you need to come back and work for the next hypothesis. Now, what should be the nature of these conjectures and these theories? Like, what should be the properties of a scientific theory? Now, this is also a very important thing for all of us, that how you can come out with a good scientific theory, because this is also what should I say, this is also an important factor for all of us to understand that what makes a good theory or what makes a good scientific theory. So the first point which he talks about is that it should increase the prediction level, right? So a good scientific theory will be one which has the capacity to increase the prediction level, right? Like the suppose right now we can predict up to, say, like suppose if there is an app which we have in our say smartphones, and we want to know that okay, we are traveling next week to some city B, so what is going to be the weather condition of that city, so that we can accordingly pack. So we can see that next week the weather will be like this and this and this. Okay, we know whether we need to take our jackets and coats or whether we can just go in our t-shirts. Now, if I am planning to go after 3 months and I check that app and I find that no, it is not having that level, it cannot talk to us or it cannot tell us what will happen in next 3 months. But if there is an app which can tell us that okay, what will be the weather conditions even after 6 months or so, I do not, I'm not questioning or I'm not putting anything like that this is not possible or why these apps cannot do and so on. What I'm saying is that if something is like that, that it can go for a higher prediction level, so this is a good scientific theory because it is increasing the prediction level, right? So this is one thing. Second, it should also have more precision. Now, what we understand by precision? You all, or we all understand what is precision, right? Like suppose there is a satellite which is taking images of a place, right? And whenever we zoom it, so we know that the images are accurate up to say 5 meters. Like suppose if something is said that it is here, located here, so it will have a say error of at max 5 meters, right? So it will be 5 meters here or there, but not more than that. Now, if suppose even a far better camera with which we are using the satellite, or the satellite has come closer and it is taking far better pictures or something like that, we can have the precision level and the error has been reduced and the precision level is say 1 meter, right? So that will be like again a good scientific theory, right? uh, Popper also said that whenever we are making a scientific theory and suppose something has not worked, like we talked about this conjecture and refutation, that we put an hypothesis 1, the hypothesis 1 was found that there are certain problems with the hypothesis, so we need to come back and propose hypothesis 2. But usually in scientific behavior, there can be makeshift arrangements. So Popper was completely against makeshift arrangements. He said that there should not be any makeshift arrangements. Now, what does it mean? You should not try to eradicate a problem by making small changes in your theory. Rather than you should come out with a new theory so that it not only takes care of those small problems which were coming, but it may be also futuristic by nature, right? So no ad hoc moves or no makeshift arrangements are allowed from Popperian point of view. So this is another important thing which Popper said about the scientific theories. Now, a good scientific theory also has some more properties. Like a good scientific theory has to be imaginative, right? Or creative. Because we do not come out with a scientific theory, or we do not call something a scientific theory if it is not imaginative or it is not creative by nature. Look, usually what we do as scientists or what we do as researchers, we try to find a base theory and on that we make small improvements. Those are innovations. According to Popper, or according to this line of thought, it has to be an invention rather than an innovation. We all know what is the difference between invention and innovation, right? So a good scientific theory will be a scientific theory which is more imaginative, more creative by nature, and works on a very different platform than the platform which we were using before, right? Like we know that we use one platform, then we change, we make some changes and we come to another platform, then we also make some changes and we come to another platform, and so on. Then there is one platform and there is a completely different platform, right? So a more or a good scientific theory will be something which will be more imaginative and creative by nature. It should also has it should also have risk factors. This is something also which I told you, that it should have risk factors, and it should be very risky by nature. Now also Popper says that sciences can or scientists can work both as individuals as well as groups, but then he has something more to say about these things, that how people should work as individuals and how people should work as groups, right? And that is not only a scientific behavior, but it is also something which we all should understand. Like, for that matter, let us try to understand. uh, Individuals, or say a single individual, can work on his or her theory and can come out with the possible observations which refutes the theory and can come out with another theory. Okay, so this is something which is the work of an individual which can be done. Similarly, a group of individuals can also work or also do certain kind of theories, or can propound certain kind of theories and work for it. Now, who it should not be the case that suppose we are working in a group, say like 5 people are working in a group, I do the work of propounding or conjecturing a theory and somebody in my group only is rejecting that, right, or is refuting that. So that is not a good scientific behavior. Rather, I myself should find the problems, and myself should try to do something good to the theory. In fact, if you try to understand it from another perspective, like suppose there is a group of scientists who are working on problem P1. Okay, this is group G1 who are working on say problem P1, and they have an hypothesis H1. Okay, and they see that whatever the problem was say working with all the observations. So observation 1 and observation 2 actually was making this theory a good one, but then say observation 3 brought us down. So you need to come back to this stage and go for H2, right? Now this is something which should be done by this group. Now consider that there is a group 2 which also works like this. So they have a problem P2 and they have observations like this, and say the observations are say M1, M2 and so on. Now it is not a very good scientific behavior to take this observation and bring this theory down. You should work for your principles and your theories and let others work on their principles and their theories. We should not, because try to understand this thing. We should not be doing this to us as well as to the scientific community, that we become only critical about something. Rather than constructive criticism, we are only criticizing somebody's work and criticizing and finding faults with somebody's work rather than propounding something. So we should have our own business to manage. People have their own business to manage, and if they are finding something wrong, there is something called a character of scientist as well. You need to have a very good character. The good character understanding of a scientist mean that whenever you find that there is an observation which does not make your theory good enough, you need to change your theory, or in fact you need to come out with another hypothesis. You should not make makeshift arrangements, right? Like what we discussed on point number 3 or 4, that you should not come out with some makeshift arrangements, some ad hoc moves and so on. Rather than you should come out with another theory. And similarly, it is not another group's task to bring somebody's theory down. What is happening these days, that whenever we are in a scientific environment, you will find a group of people who are working on certain things, another group of people who are working on those people who are working on certain things and their theories, and trying to prove it inconsistent. Now this is something which should not be the behavior of a good scientist. So that is also something which Popper was very well aware of, and he talked about those things, that a good scientific theory should be risky. It should not be like that, okay, I will make a safe move. People should not target innovations, they should target inventions, right? I will be taking a lot of examples for these things in the later part of this course, and mostly those examples will be examples which are based on our mobile phone understandings. Like for the time being, let us try to understand. Like we have a smartphone, and I see the smartphones have dried completely for last 5 years or so. There is no extra feature which is added. If you consider an extra feature like face recognition is an extra feature, or my cornea is an extra feature, or that fingerprint is an extra feature, or a good camera is an extra feature, I do not consider it to be an extra feature. What is more important and something is that there is no invention which is coming on mobile phones. Like right now you have seen that there is a flip phone which has come, but flip phone is also not something which I will call. Rather than I wait for a day when I will have a small phone in my hand and I can stretch it and make it bigger, rather than I I open it as a flip, right? Because these flip phones were available beforehand, before as well. The only difference which it has come is that one part was the screen, the other part was the button section, and now both of them has become a screen. So you get a bigger phone, or say a bigger display, which you can fold. But I want something which can be stretched, something which can be stretched and will become bigger. So if you see the mobile phone industry or so on, right now there are no more inventions which are coming on, rather than innovations which are coming on. And according to Popper, that is not a very good scientific behavior. A good scientific behavior will be that you come with innovations. Inventions. And I strictly look forward to that there will be some inventions in the field of sciences which will bring some more things to us which we still are not getting. So I will complete this lecture here only, so that you have this idea. You will get enough of material on Popper, and therefore I am restricting my discussion over here. I am also keeping the video shorter, so that you get the idea of Popper, and then you can read on your own from a lot of text which we are also sharing on LMS. So thank you very much for watching.